Good morning, children. So, students, welcome back once again with a new chapter on chemistry, that is physical change and chemical change. See, you have a little idea about physical changes and chemical changes. Now, see, once you have different ideas about physical changes and chemical changes, today I will be showing you some changes over here, and then I will explain you the properties of physical changes and chemical changes. See, physical changes, you all know that they have certain characteristics, and chemical changes, they also have some characteristics. But to understand the characteristics, to know about the characteristics, I will show you some reactions over here. Now see, look very carefully over here. See, this solution, okay, this particular solution, if you look carefully, nothing is there. It's a clear solution over here. In this, I have added sodium hydroxide with water. Okay, what I have added it over here? In this mixture, I have taken sodium hydroxide with water. Now on mixing it, okay, on mixing it, see, it has dissolved completely. The substance is completely dissolved. Now, if you heat this solution, you will get back the sodium hydroxide pellets. Okay, once you heat it, the water will evaporate, and on evaporation, you will get back this sodium hydroxide pellet again. So, over here, no chemical compound formed. Okay, no chemical compound is formed over here. Okay, no new chemical compound is formed. It's just a solution of sodium hydroxide and water, just a normal solution. See, take for example, if I give you a beaker like this, and in the beaker I have added some amount of water. To this, if I tell you to add sugar particles into it, so what will happen? After few minutes of time, the sugar particles will dissolve completely into the water. Okay, the sugar particles, they will dissolve completely into the water. Now, the moment you heat it, the moment you heat this solution, the water will evaporate out, and on evaporation it will leave the sugar crystals into that container over there. Okay, the sugar crystals will be left over there into the container. So this kind of change, where no new chemical compound is being formed, is called as a physical change. Again, you see this reaction, no reaction has taken place. I have just added sugar to the water. Now, once I have added sugar to the water, so what happens over here is that once you start heating it, the water evaporates and again the sugar is left. So, physical changes, they are reversible in nature. The physical changes, they are reversible in nature. That means if a physical change has taken place, it can be reversed back again to get the original product. See, one such common example I will give it to you. See, what the example is, let you have been supplied with a piece of ice cube. Okay, these are the pieces of ice cubes. Now, once you keep these ice cubes like this, outside the refrigerator for some time, what will happen? They will melt to form water. Okay, these ice cubes, they will melt to form water. Again, what you can do is, this water, if you keep it in the refrigerator again, they will form the ice cubes. So the process is reversible. Ice is converted to water. Again, water can be converted back to ice, isn't it? So that is why this kind of change, we call it to be as a physical change. Okay, this particular kind of change is called as a physical change. Now, one more property. So this is the reversible property. And look over here. Ice cubes, once they are getting converted into water, ice cubes, they are also made up of water, isn't it? So no new chemical compound has been formed. Ice is water, water is the same ice. Okay, that means their compositions are the same. Their compositions are not different. So that is why this reaction, that is conversion of ice to water, or the revert one, that is the water to ice, is classified to be as a physical change. Okay, because the reaction is reversible and no new compound has been formed. Next property is that the composition will remain constant. Okay, the composition will remain constant. See, why the composition is going to remain constant? Because no new substance is being formed. So where will the composition change? If some new substances are being formed, then the composition will change. But over here, nothing new has been formed. So since nothing new has been formed, so the composition will remain constant. Okay, so the composition will remain constant and it is not going to change. The next thing that we have over here is, in case of physical changes, no exchange of heat energy will take place. Okay, there will be no change in energy content. No change in energy content of the system. No change in energy content because nothing new has been formed. Now, since nothing new has been formed or no new compound has been formed, so there is no question of change in any energy. Okay, so there is no question of change in any energy of the system also. So that is why physical change is being characterized by these four different properties. The very first property, that is no new chemical compound is formed. Okay, no new chemical compound is formed. Nothing. No changes will be there. No properties will be changed. Nothing. It is the same parent compound that you will get. The next reversible reaction, that is, they are reversible in nature. That is, once a change has taken place, that can be reversed back once again. Okay, you may take some other example also. See, sometimes this is summer season, so we need to prepare juices and all. So at the time of preparing the juices, what we add? We add sugar to the water. So that addition of sugar to the water, that is also a physical change. Because if you start boiling that water, the water will evaporate and sugar crystals will be left into the container over there. So that is also a kind of reversible reaction. Another reversible reaction, that is addition of salt to the water. The same similar phenomenon, the moment you have added sugar, in the same way the salt will also, you will get it back after the water is evaporated. See, you have seen sea water, isn't it? Sea water, you have tasted it sometime. Yes, it's salty. So that sea water, once you have tasted it, if you keep that sea water out into the sun for a few days, the water will evaporate slowly and it will leave behind salt particles over there. Obviously, along with the salt, some sand and some impurities will be there, but it will leave behind the salt over there. So this is a kind of physical change. Okay, is it clear to you? Next, the composition will remain constant. You see, since no new substance has been formed, no chemical substance has been formed, so the change has to be a physical change. Next, no change in energy content. How will the energy content change? Since no new substance has been formed, so no change in energy also. Now see, if I move on to this portion of chemical changes, I'll show you one reaction. Look carefully over here. This is a solution of ferric chloride in water. Just normal ferric chloride solution with water. Nothing has been added. I have not added anything to it. Now, the moment I will be adding this sodium hydroxide solution to it, look very carefully what happens to it. You will see a dense chocolate brown precipitate forming over here. Okay, you can see dense chocolate brown precipitate forming over here. If you look very carefully at the beaker, you will see the precipitate is floating over here. The moment I keep this beaker for some time, you will see the precipitate will settle down at the bottom. Now, what is this precipitate for? Or why is this precipitate has been formed over here? Okay, I'll show you the thing over here. See, look very carefully over here. The thing is like this. Ferric chloride, that is FeCl3. This, when it reacts with sodium hydroxide, the moment it reacts with sodium hydroxide, it forms ferric hydroxide, FeOH whole thrice. This ferric hydroxide, okay, this ferric hydroxide is obtained as a brown PPT. Okay, this is obtained as a brown PPT. We symbolize PPT with this downward arrow. So FeOH whole thrice is symbolized as a brown PPT over here. So this is what is the brown PPT that you get it over here. Okay, this is the brown PPT that you are getting it over here. Now this is a completely new substance. I don't have ferric chloride over here in any of the part of the reaction. That means a new substance has been formed over here, and that is why this reaction is called as a chemical change. A new substance has been formed, a completely new substance has been formed. Ferric chloride reacting with sodium hydroxide will give you ferric hydroxide. Okay, and this ferric hydroxide, this is not present in any of the reactants over here. So this is a completely new substance which is being formed over here. So that is why we will call it to be as a chemical change. So chemical change, the very first point that you will get over here is new substance is being formed. Okay, the very first one is new substance is being formed. Now, the next point, this reaction is not a reversible reaction at all. The reaction is not at all a reversible reaction. Why is it not a reversible reaction? See, look very carefully. The reaction is not at all reversible because from ferric hydroxide, I cannot get these two chemicals back again. I cannot get these two chemicals back again by any of the methods. So that is why the reaction is irreversible in nature. Irreversible means it cannot be reversed back once again. So the second point that I am having is irreversible. This is the second part for a chemical reaction. The next part for the chemical reaction is that the composition will change. Okay, there will be a change in composition. Now, how the composition is going to change? Look very carefully over here. See, in this particular reaction, I am having ferric chloride and sodium hydroxide. But what am I getting in the product? I am getting ferric hydroxide in the product. Now, ferric chloride composition is different. Sodium hydroxide, it also has a different composition. And the ferric hydroxide that I am getting over here, its composition is also different. So, there is a change in composition due to the formation of new chemical substance. There is a change in composition due to the formation of new chemical substance. So these are some of the characteristics for the chemical changes. Now I will show you one more chemical change. Look very carefully. See, this is a candle. All of you know it. And the moment I want to light the candle, I'll use a matchstick for lighting the candle. See, this matchstick, once it strikes the surface, the matchstick is glowing. This glowing matchstick, this is a kind of chemical change. Why is it a kind of chemical change? I'll show it to you. See, I have already lighted this candle. The moment I have lighted this candle, you see the candle is burning. The moment the candle starts burning, okay, the moment the candle starts burning, you will find the wax will also melt. Okay, you will find the wax will melt. This melting of wax and burning of candle, these are two different types of reaction. I'll explain it to you now. Just look, see the candle is burning, it is producing heat and light. That means a chemical change is accompanied by production of heat and light. That means energy change is taking place over here. Okay, energy change is taking place over here. See, the candle has started melting. Okay, the candle has started melting. That means the wax is melting. Melting of wax. There is no change in chemical composition of the wax. The wax will remain same as it was before. So there is no change in the composition of the wax. That means melting of wax, that is a physical change. But burning of candle, that is a chemical change. See, once I blow out this candle, you will find a dense white fume over here. See, look very carefully. The moment the candle is blown out, you can see dense white fumes coming out from the candle. This is because of a reaction that has taken place. And what is the reaction? The reaction is due to burning of candle, it has produced carbon dioxide and water vapor. Okay, burning of candle, it has produced carbon dioxide and water vapor. Because of the formation of these two compounds, you saw the dense white fumes over here. Because of this burning of candle, since carbon dioxide and water vapor have been produced, that is why you saw the dense white fumes coming out from the candle once the candle was blown out. Now, melting of wax. See, once the wax has melted, it solidifies again. So, there is no change in the chemical composition. But for this matchstick, see, the matchstick, once it has burned out, I cannot burn it again. I cannot burn the same matchstick again. So, that is why burning of a matchstick is a chemical change, because that is irreversible one. Okay, burning of a matchstick, that is a chemical change because it is irreversible one. And for the candle, okay, I am having this as the burned out product, that is carbon dioxide and water vapor. So, burning of a candle is classified to be as a chemical change. But remember very carefully, melting of wax. Just I want to melt the wax. Just simple melting of wax. No reaction, nothing. I have not added any chemicals, nothing I have done. So melting of wax. Okay, melting of wax, that is a kind of chemical reaction. No, melting of wax is not a kind of chemical reaction, but it is a kind of physical change. Okay, melting is a kind of physical change. It is not a kind of chemical change. Is it clear to you? So, I have taught you about the different characteristics of physical change and chemical change. I have shown you the reaction. See, if I give you one more example, see what I have over here is hydrochloric acid. You can see it's a concentrated hydrochloric acid. See, dense white fumes are coming out from here. This is a silver nitrate solution. The moment this HCl is added, you can see it is forming dense white precipitate over here. So what is this dense white precipitate for? Or what is this dense white precipitate called as? See, the dense white precipitate is for a reaction that is taking place over here. Okay, what kind of reaction is taking place over here? See, look very carefully over here. It's a kind of chemical change that is taking place over here. Now, what kind of chemical change is taking place? Let me explain it to you very carefully over here. See, once you are adding silver nitrate, AgNO3, it is mixed with water. Okay, silver nitrate, this is mixed with water. Okay, it's a water solution we have taken. Okay, for silver nitrate, we have taken water solution. You can call it to be as aqueous solution also. To this, you have added HCl. HCl is hydrochloric acid. We have added hydrochloric acid. The moment you have added HCl, what will happen? A reaction will take place. In this reaction, it will form silver chloride. Okay, what will it form? It will form silver chloride as a white PPT. Okay, it will form silver chloride in the form of white PPT. Now, this silver chloride which is formed over here as a result of white PPT, this is a complete new substance. This is a complete new substance. It has got no relationship with AgNO3 or HCl. It does not have similar composition to that of silver nitrate or hydrochloric acid, isn't it? So this compound which is formed over here as a result of the reaction, okay, we call it to be as a chemical change. Okay, the change is classified to be as a chemical change. Now listen very carefully over here. What happens is that this change is